in order to find anything about a star, we need to find its distance, okay? Because once you know the distance, you can measure its brightness. Then from the distance and the brightness, you can determine its luminosity, that is overall energy output per unit time. Then using the spectral analysis, you can find out the surface temperature. From surface temperature and luminosity, you can extract the radius of the star using the Stefan-Boltzmann's law, and so on, okay? So the first thing you need to find out about an object out there in the universe is it's the distance, right? And so I want to discuss next measuring the distances to galaxies, okay? So even for those that are closest to us, like the, say, Large Magellanic Cloud at 170,000 light years, already at that distance, the parallax method fails. We cannot use stellar parallax to measure the distance. So what to do? Well, for those that are not too distant, we can actually use the method of Cepheid variables invented or introduced by Henrietta Swan-Leavitt and used by Harlow Shapley to determine the size of the Milky Way by measuring the distances to the globular clusters and also to determine our distance from the galactic center. So for the galaxies that are not too distant, one can use the method of Cepheid variables. If you recall, one uses the period luminosity relation for such variable stars, and then determines from the period of their oscillation, their luminosity oscillation, one can determine the peak luminosity. Once you know the peak luminosity, again, you measure the brightness of the star, and using the relationship between brightness, luminosity, and distance, you can find out the distance. Obtained using the Hubble Space Telescope. And here you see in the insets photographs in a particular portion of the galaxy showing a Cepheid variable. As you can see, here is this variable star. Over time, its luminosity increases, right? So here is low, gets brighter, and then brighter again. And then it decreases again. And you can measure the interval of time from, say, maximum brightness to the next maximum brightness. That gives the period of luminosity variation. Then you go to that luminosity period curve and read off the luminosity, and then from known luminosity you find out what the distance is. So here we have luminosity, here we have period, and the curve looks something like this. And then you measure the period, and then read off the luminosity. Right? So you measure the period, and then you read off. So once you know the luminosity, you then go to the relationship between brightness, luminosity, and the distance. You again measure the brightness, and then you deduce the distance. Okay, so fine, but this method doesn't work for galaxies that are beyond 100 million light years. It will fail for the galaxies that are more distant than 100 million light years. Okay, but at greater distances, we just can't see them, right? So something else has to be devised, and we'll discuss that on Wednesday.